Hello, how is everyone? Just making sure my microphone's working. Mic check 01. I didn't write any new raps for today. In fact, I have done very little for the last week. I've been on leave, so I've been alternately playing with my little miniatures or playing computer games and just very much chilling out. So you're going to ask me questions and I'm going to say, what is programming? I don't understand what this programming thing is you talk about. I've been avoiding it for a week. Oh, Tom thinks I was freestyling. No. It's kind of like I try to make it look like I was freestyling, but it was like... what is it? It takes me like an hour the night before to be, I could say this, and then I could say this. It's really funny. They come in the shower, basically. It's just like, I'm just there, and it's like, I could say this, and I could say this, and it's like, I need to write this down when I get out. Okay, so, today we have a little bit of time. I have nothing specifically planned for today, so I don't have anything that I need to show you, or and I don't have anything that I've prepared as like tutorial kind of things for today. So today is very much a by request stream. So if you have anything that you want to know about, or anything that you've been studying and you think that's a bit weird, I don't know if I fully understand this particular topic, those are the things I'm more than happy to cover today. We can go back over lecture slides and stuff. I just realized I didn't have the lecture slides prepped and ready, but I'll get them going. I also, as you can see, have VLab open so I can do live demos. I think that's all the slides. Yep. Okay, so happy to open this up now, right from the beginning, for any questions. If anyone has anything they would like to know about or anything like that, feel free to ask now. And if you don't, I will have to make something up. Oh, Kat has $1 million question. Not specific to programming, but how do you study? This is a tough call. Let's approach study like it's an engineering problem. So, let's leverage what we may or may not have learnt. It depends on what we've been doing, but what we may or may not have learnt about solving problems. So, if we consider an exam to be a large problem, the large problem has certain constraints around it and certain measures of success. So, you're going to get your baseline success if you get 50% of the exam correct. For some of you, you may be very confident of how you're going at the moment, and so it may even be less than 50%, but let's just assume that there's that baseline. For some of you, you put a lot of pressure on yourselves, and so your baseline's higher than 50%, but whatever it's going to be, you're going to say, I need to get a certain number of marks, and if I can get that certain number of marks, then I will be happy with what happened in the assignment. So, you've got a task you have to complete, and then you have a way in which you can get that. So for 1511, we can see that we have 6 hours with which to present the best work that we can do. And I think that the way to look at it then is, I am under time pressure to show a certain level of capability. In which case, as we know, anytime that we're going to work under time pressure, the level and type of preparation that we've done in advance is the thing that is going to get us good results. So I have a feeling what you can do there to be the best is to say, what kind of ideas or techniques am I going to need to do in the exam? And so you can look at those examples we've given you of things in the past. You can practice for similar types of problems. The other thing that you can do is to say, I need to understand the core ideas of what's going on, and to be able to put those into practice at speed. So I think one thing that you could do, I'm not sure if there's an easy way to do this, but if you could, for example, write down the questions from all the labs and the tutorials and then randomize them, pull them out one at a time, and just look at it for 1 minute and say, this is the approach to that. So this is learning about approaching the problem correctly by saying one of the things that's most important for any question in the exam is, how do I approach this? And this is going to be like something that you do in computing in general or in engineering in general, is the ability to identify what solution should be applied to a problem is probably one of the hardest things. And I think that's good training. So if you can have questions pop up in a way that you're not prepared because they're not in topic order or anything like that, then you can say, this requires this kind of approach. So for example, I could say, reverse a linked list. And you say, okay, to reverse a linked list, I need to loop through the linked list to get the final element. And then I'm going to use that. And so I know that certain techniques I'm going to use. Or I can say, I'm going to do recursion on this. I'm going to stop when I reach the final element. I'm going to keep going if I haven't reached the final element, that kind of thing. But the ability to say, I'm going to approach this question with this type of solution, allows you to then have broken down the problem into parts. And so we get back to that kind of engineering principles of problem solving being the ability to break something down into its parts and then solve each of those parts separately because they're much easier to solve. So one thing that I think is very good for study is to figure out how you're going to approach each problem so that when a problem hits you and it's brand new, you've already practiced hitting brand new problems and being able to solve them. So I think that kind of high-speed identification of potential solutions is something that would be nice. And I think Tom has given something there saying extra practical advice on study is go through every lab exercise and topic and rate them between green, yellow, or red. Like easy, I know it'd take me some time, or I don't think I could do this. That's actually a really good thing to do, because then you can identify problems later. Again, the exam is about showing what you know. And so it's a little bit of showing what you could work out at the time, but really it's more about showing what you've remembered previously. So I think putting yourself in a mindset where you can say, okay, if I want to be able to remember things quickly in the exam, then I'm going to want to have a solid grounding in the kinds of things that might be in the exam, which is basically the course content. So as Tom's saying, if you can check out what you've learnt in the course and how well you know the different parts of it, you'll be able to look at those questions. You say, okay, I can complete this or not. So I think a lot of the preparation, I mean, definitely as you're going through your preparation, like as Tom's saying there's a bit of self-reflection there, which is go through and figure out what you're doing well and what you're doing badly. So what do I understand about the course and what do I not understand about the course? And then you know which bits to focus on in your study. You do want to do an overview of everything in the course, as we did in week 10. We did that. That was months ago now. I love it was last week, but because I took a few days leave, it's like I've crossed over a boundary and I'm in a completely different world now. But as we did last week, looking at going through everything and just looking at it all, and it's not too bad if you go through. You could even go through my lectures again, the 1.5 lectures, which is the overview of the course, and the bits where you don't get it, because you'll know there'll be gaps. There'll be bits where you go, okay, I know this, I don't know this. If you don't know it, pause it, write down the topic, and say, okay, need to go back over this. So that's a good way of targeting the things that are going to cause you problems later, because we're going to assess a breadth of information in the exam, and so you want to at least cover a bit of that breadth. I'm trying to think of like the nitty-gritty of studying. Like once you get down to deciding what you want to do, I think between now and the exam you've got nearly exactly 7 days between now and the exam, and some of you can have other exams as well, so it's not something that you're going to be able to put an unlimited amount of time into. You need to target that time, so you need to be very practical about which questions you do have time to study and which questions don't. And I think it's good to look at any topics that you can find where you didn't think any of the questions were easy, and you say, okay, I need to look at the baseline necessary in those topics and do a couple of those questions. So focus on getting the breadth of the course all up to a certain level, and then go higher if you can, or if you've got time. Yeah, I think that's... I'm not sure what else I wanted to say about study. I think that I'm probably not the best person to ask about study. I can give a whole lot of this theoretical information about it, but in terms of practical study advice, I haven't studied recently. You know, like all the work that I do and all the thinking and study that I do is how do I present a topic in a way that's going to be digested in the clearest fashion. So like me studying is very different. If you're doing a teaching degree, I could talk about studying about that, but I think it's slightly different, right? So, but I think that you can definitely talk to other students about this, and Tom had some advice there. Okay, Kat says it did help, so I'm happy with that. All right. Okay, so next question there was Adam. Quick question about arrays. When defining a function that takes an integer array as its argument, is there any practical difference to the function int array max size versus function int array empty? Okay, let's have a quick look. We'll just open gedit. So, I should have. I realized I should have saved this as a C file. I'm just going to call it demo because it's going to be like a scratch file for me to just write stuff in. So, two possible functions here that Adam's talking about. I don't know why I made this an int function. Could be or could not be, that's fine. One of them was an integer array of let's say 1024 as our max size. This takes in an input array of max size, and this other one takes in an input array. So the question was, what is the difference between these two functions? The difference between these can kind of be thought of as what happens inside is that this function can work with the assumption that this thing is a particular size. This one won't. I think it's probably worth testing this as well to see, because I don't actually... I have this problem, right? This problem where I only ever do things exactly the right way. And I think it's worth testing this by throwing stuff in that's not exactly correct. So, for example, if we were to do something with this, and I say, let's do like a really, really basic while loop. I is less than max size. Okay, just something really, really basic where I'm just going to write the number into the array as I'm looping through it. And let's try making an array of size 10. I'm going to set it up as zeros to begin with, and then I'm going to say, oh, this is going to need a return. Let's return I, because I could have made it a void function actually. I'm going to say I reached a certain number using the array function, and let's put this array that we've created into it. So let's have a look at what happens if we put the wrong sized array into this. I wonder if it's going to compile or not. I think I did this in the live stream directory, didn't I? Okay, unused variable, that's fine. I've made a number but not used it, but it has let me compile this. So we can see that there is a mismatch here between what this thing is expecting in size and the thing we gave it. I have a feeling that this is still going to run, but it's obviously going to break when we try to write into the array outside of bounds. But let's see what happens. Okay. Oh, I know what just happened. I forgot the I++. Take 1 week off and forget basic looping. Okay, let's compile this and run this again. I'll just make sure, see if Adam is talking to us there. No, not necessarily. Okay, let's run this again. See what happens. Okay. Stack buffer overflow, which is something that happens if we have gone outside of the stack. And remember, the stack is where our functions are and stuff. So I had memory for that function, I've gone outside of it. So I've gone past the end of a local variable, which means that when we look at this carefully, what we're seeing here is that this declaration in the function of the inputs of the function does not actually force us to only take arrays of a certain size, because when we pass an array into a function, the only thing we're giving the function is the memory address at the start of the array. The function variable itself doesn't actually give the information back of how big the array is. There's no way to actually ask an array what its size is. So we actually need to know what its size is. The thing that this gives us is a very human thing, is us saying to whoever's using this function anywhere that this function's only going to work if this is this size. If I say this, then I'm saying that this function's going to work with any particular array size, in which case we probably want this. And I would nearly say that this... I bumped one of the thumb buttons on my mouse and blew up everything. I would nearly say that this is potentially a better way to do all of your array functions, unless you're really, really clear that this is always going to be the case. So this one has a margin for error, but then also it's really, really obvious that it's saying, I work with this, so you should never put in something like this with the 10. If this had been max size, it would have been okay. Whereas this one here is saying, I don't have any specific idea about the size of the array, but if you tell me the size of the array, I'll use it, and I'll do what I consider to be the correct function there. So if we build the same array, the same kind of looping through the array, we now can be in a situation where it's like, all right, we're not going to, this function is not going to particularly say I can or can't do whatever you're saying about the array size. But so I'm not assuming anything about the array size. I'm asking specifically. So if you tell me how big the array is, this function now works on many different possible arrays that you can create in your program, whereas this function only works on arrays that are specifically this size. So I think that would be the difference between saying I'm not going to declare the size of the array and I am. It doesn't programmatically stop you from using any array in either of these functions. But this one says I will specifically be open about the array size and ask you to give it to me. This one says I was intended for a particular size. If you don't give me something of this particular size, I may not work. So this one is like sort of trusting. I mean, both of them are. This is trusting the human to give me exactly the right size when they call this function, when they've written the code. And this one is saying, when you call this code, you have to know the size of the thing that you gave me, and you have to tell me that size, and then I'll do what I need on it. If we have this, then this is probably the worst of all possibilities, in that if we don't know the size of the array, then we can't loop through it. We don't know when to stop looping. So either you say really, really clearly, this is the size of the array going in, or you say, I'm going to undo so this reappears, you say, every time you call this, you tell me how big the array is that's going through, and then we'll go through it. So hopefully that answers that question there. Okay, so that was Adam's question. Zol was saying, I've been struggling with week 10 test question 4. When I create the before list, I can't set it as null, so I won't be able to assign its data value. But if I don't assign null to it, I get an error that's uninitialized. How should I initialize a struct in that kind of situations? Let's have a look at week 10 test question 4. So I'm assuming, wait, is it the weekly test or lab? I assume, because the weekly test usually doesn't have a question 4, but this one has something in it that is at question 4 level, right? Q1, Q2, it would be this one, I assume. Split a list into 2. I mean, I think, Zol, you may have your answer there already, that Anu was saying you may have to malloc it. Just looking at Tom's answers to people's questions there. Okay, so Zol's saying, question 4 says I should only call malloc once for the split list, so I'm in the right question here. So I can't malloc for before and after lists. Yeah. Okay. So split list says I have a list and it has 1 0 in it, and what we want to have is a link to the list with everything before the 0 and a list with the 0 and everything afterwards. So in approach to a problem like this, I'm not going to go straight to code, as you know, you all know me well enough to know this. I'm going to set up a hypothetical situation and then I'm going to look at how I would approach it. So here's the list I've been given. I will be given a pointer to the first element of the list, and that will be the head. Okay, so I've also been told that somewhere in this list there's a 0. So let's put a 0 here, and let's put some other numbers in here. I've been told that there's a particular struct that I'm supposed to give as output, which is a struct split list, which has a pointer to the node before and a pointer to the node after. And before should have a list, a complete linked list with everything up until before the 0, and after should have a list with everything after. So my struct that I'm going to create, it's another color. I'm just going to call it split, is going to have a before and an after. This has already been due, right, Tom? It's okay if I work through this. I just thought I should check. It was due yesterday, right? So I think it's okay for me to work through this. Yeah, saying there's no malloking involved and stuff. Oh, Dean's here as well. Hey, Dean. Okay, so I'm back on a question about week 10, question 4, that people were asking about. Okay, so it's saying that we shouldn't malloc anything, right? So the key, one of the key things it's telling us is I can't create new nodes. Yeah, so I'm not allowed to create a new node like this. So let's just undo that because I'm not allowed to do that. What I have is these nodes here that are in memory, and I can only reuse these nodes and change what pointers are aimed at them so that they will create a list. So the outcome I'm looking for is 2 lists, one called before or one called after, which means I'm going to need this thing to now be 2 lists, not 1 list, which means they're both going to have to end pointing at null. They're both going to have to start on particular nodes that exist here. So what I might do is I might loop through this list and find out where the 0 is. So if I malloc the split, then before and after don't have any information yet. One thing I know for certain is that since I'm splitting this into 2 lists, the before is definitely going to be pointed at the head, right? Because the answer is that the split the list into a list with everything before the 0 and a list with the 0 and everything after. So I know that my before is going to be pointed at the start of the list and my after is always going to be pointed at the 0. So what I would do is I'd loop through this list and I would find these elements. So before is easy because before is just, I'm going to do a copy of head. So if before is a copy of the head, then it's pointed at this. Then I loop through the list until I find the 0. When I find the 0, I can say, okay, after is pointed at that. Now I've got half of my solution. So the only malloc I would do is to create this split here. So I would malloc the split and then I would populate the 2 fields inside the split struct with some information. And I think the information is going to be the memory address of the first element of the list and the memory address of the element that contains 0. Because I've been told there's exactly one element that contains 0. I have to find it. So in order to find it, I have to loop through the list. The next thing I would have to do, though, is this is not split up into 2 lists. This is 1 list, and I have pointers to some parts of this list. So what I would have to do is I would actually have to split this up into 2 lists by breaking the chain somewhere. And we can already see where the chain has to be broken is because it's this pointer here. This pointer here, this list is supposed to contain all the elements before 0 and nothing after that. So if the next of this element points at the 0 still, then this first list is still the full list, and we needed 2 half lists. This second one's actually already done, because it has the 0, everything afterwards, and then a null, so this is complete. We don't care that something else happens to be pointing at this. The after points at a linked list that continues on to null, so that's fine. So what I need to do is I need to take the before list, and I need to say, okay, this one goes to 5, then it goes to 1, and it can't go to the 0, which means that this next pointer here off this one should be null. So I would find a way to find this node. I would maybe think of looping through until the next is pointing at the same thing that after is, and then I would stop there and say, okay, now erase next and change it to null. That's how I do that. 1 malloc only. Nothing else has happened. I have set up these pointers after mallocing the split. But I have a reasonable idea about how I would do this thing, so I can have, at the end, 2 complete linked lists. I won't necessarily do that in code right now, but you see what I was talking about earlier, so Zol's saying that makes sense. Yeah, cool. I'm glad you're getting that. This is what I'm talking about for learning the approaches to solving a problem. So you look at it and you say, okay, how am I going to break this apart? And you can see how, like, you may have even been able to notice me look at that question and read it, and then you would have seen a pause in me there going, oh, how am I even going to solve this? And I'm going, why am I even thinking that? Why don't I go to a picture, right? And I can draw this thing out like this, and I guarantee you that if I had gone straight into gedit and started trying to code the result of this, as opposed to going straight into Paint, or, like, if you don't have to, like, stream it to people, you can do this on a piece of paper, it's much quicker. You can see how immediately I was more effective at solving the problem. And if I was to go back in time and do that by going straight to code instead, I don't think I would have gotten the solution as easily as I got it there. Like, it was really easy to see what's going on. So this is what we're talking about studying. This is perfect, right? If this is the way you study, where you go, look at this question, how am I going to solve this? That's my first approach to solving these difficult linked list problems and like asking about malloc and stuff like that, is to say, how do I approach this? And then you can look at it and go, okay, if I draw pointers as arrows and I draw memory allocated things as blocks, then I can see how everything attaches to each other, and I can see how I'm going to manipulate it. Hey Shrey, how's it going? Okay, so let's go back and see what other people were saying. So Zol got a good, hopefully a good response there that lets you understand that better. And Anu was looking at the same thing. Knox is asking if we receive an email on the day of the exam or before, and I think that Tom has already answered that, in that you're going to receive an email before the exam. So I can't remember when exactly, but I'm expecting those to go out Tuesday, Wednesday-ish next week, so that you know that you're prepped and ready for the exam, and you know if you received that email, it's highly likely that you will receive the proper email on the morning of the exam. The email that goes out a few days before will actually have the link to the exam. It just won't work until the exam's officially open, right? But at least you'll know that you've got a few days in advance to go, okay, I have the email, it's fine, I have the link to the thing, I will wait until midday on that day, and then I'll try to use that link. I mean, it won't be like, we'll try to be dead on midday, but, like, you know, everyone's clocks are a little bit different. So don't just spam that link the second your clocks get to midday. But you can definitely, like, what we will most likely do is we will send emails out to everyone to say, okay, exam is now live. From the point at which we make it live, there's 6 hours, you know, that kind of thing. Okay. I think I'm seeing midway questions from Zol there, but I think we got through it. Uditha is asking, will answers to all lab exercises and weekly tests be uploaded before the exam? Yes, they will. I think the biggest one is that one I just worked through there. That weekly test doesn't have its answers up yet, definitely. And I think some of the previous weeks haven't, because usually I would update that during the week, but I've been on leave this week. So I'll try to do that this afternoon or early next week, or maybe on the weekend. I'll end up working a little bit on the weekend, I'm sure. I will go through and I will open up the whole course. You do have to log in to WebCMS to see solutions. So we only give solutions to people who are enrolled in the course. They won't be publicly visible. So you'll notice that there's a difference to what you can see based on whether you have signed in here or not. So if you signed in, you can see solutions to tutorials and labs. Here. Wait, That one, yeah. So up there will be, if it says login or sign in, it means that you aren't logged in, which means you won't see any solutions. But if you are signed in and you've got your profile picture there showing that you're signed in, then you'll be able to see solutions. And I think we will be making them all available very soon. I think most of them are already available, but as like we've got this sliding window of what becomes available as the weeks have been finished and then marked and then they're available. Nox is saying the way to approach a short answer question will be exactly the same as what we did for the week 10 lab. Yeah, so the short answer questions will have a text file, and the text file will have really clear sections to say this is where the answer to that question goes. They will also have some very, very mild auto testing for those. They won't really tell you whether your answer was correct or not, but they'll tell you whether the format of your answer was correct. So if you accidentally answer the questions in the wrong order, for example, and you say option B for a multiple choice question when that question that you accidentally answered in was actually a short answer thing where you're meant to type some text in, it'll tell you that's the wrong format, so it'll catch some mistakes and it'll let you know whether you're in the correct kind of machine readable format for our computers to mark the questions. Numit's asking, can we use different libraries in the exam? Yes, you can use libraries in the exam. There might be, but not 100% likely, but there might be certain questions where we say you can't use this library in the question because the library trivializes some part of the question. Having said that, it's unlikely. I don't think we're not really planning on writing questions where you can't use libraries more often than not, because we use the libraries a lot. We write questions with those libraries in mind and then expect you to use them. The standard libraries are all definitely available for most questions, in that like when you think about it, that heaps of the questions in this exam will be impossible without standard io.h. Like if you can't output anything, we can't test it. And standard lib.h for your malloc and your free and stuff like that. So a lot of those are nearly going to be in every question that you answer. Just looking at people's questions. People were discussing. I'm just going back through the chat, and people were discussing that example as I was doing it. About when you malloc. Yep. Kunatai Radar Challenger says, I love it when people have like their own YouTube channels and stuff like that, and they happen to be in the course, and it's like this whole other world. Just wondering, with the knowledge gained from 1511, what kind of projects can I work on to get better at C? I think Tom's got a good answer there. You can take your assignments and extend them, or you can think about what kind of structures we've put together and things that you could make out of them. So I don't know if you're interested in games, but I would look at the idea of making like when I say roguelike, I mean actually roguelike, like the game Rogue. It was a 2D grid with ASCII art, right? You could make a game like that out of stuff that we did in the first assignment. I noticed that your icon is a plane and your name is Radar Challenger. You could do an air traffic control simulator based on linked lists of planes coming in queues from different directions and things like that. I don't know exactly how all of that stuff works, but I'm just guessing that you have queues of planes and you need to service the ones that come earlier, or the ones that go into a different priority level, so that maybe they go into different queues or whatever. So you could totally do that as an extension on your learning about linked lists and stuff. That might be really cool. Jing Yi Song is saying, I'm still confused about You say Strack, I assume stacks there. Will our exam cover it? There might be some stuff about stacks. So, as you know, stacks were not fully taught. Like, they were taught in lectures, and there was a tiny bit in the tutorials, but there wasn't really labs or weekly tests. There wasn't time for that. So it's sort of an extension topic. So as much as they will be covered in the exam, you'd still potentially be able to get a mark like 80 or 90 in the exam without knowing anything about stacks, right? So it's not a super core topic or anything. It's like, if you don't know anything about linked lists and you go into the exam, you will probably fail the exam. If you don't know anything about arrays, you go into the exam, you'll probably fail the exam. Whereas if you don't know anything about stacks, you can still probably get an HD. Having said that, they will potentially be in the exam. So the things that I would think about is conceptually what a stack is. So it's things piling on top of each other. And you can only access the thing on the top of the pile, because if you were to pull something out of the bottom of the pile, everything would fall over, right? So you can think about it conceptually like that. And if you're thinking about an actual implementation of a stack and how you would do it, I think that's a bigger topic. Better to go back to my lectures on it and say, okay, this is how we build the whole thing. However, the good thing is the question right after that NASA is asking is, do you mind coding the matching brackets program for week 10 tutorial? We can do something like that, yes. I'm not necessarily going to code the whole thing. It might take ages. But, you know what I can do is I can draw a picture for you. And then we can think about how to translate into code. I don't know, NASA, if your question is more about you understand the concept of what you want to do with matching brackets, and then you want to be able to translate that into code, or you're thinking about you're not even sure how that problem is solved. But that's a stacks problem, and so I will go through that in a second. Anu's asking, is there recursion for the exam? Well, there's recursion for the exam if you use recursion in the exam. And if you use recursion in the exam, then there might be recursion in the exam. I always love that. So you're always going to get the same answer from me about recursion. I'm going to make it into a recursive answer all the time. Recursion is a technique that can solve problems. You will be given problems in the exam. If you choose to use recursion to solve those problems, then it might do something. Otherwise, all of the problems in the exam are solvable without recursion. I mean, we've shown that even in the recursion lecture. I took something that was really, really hard to solve without recursion, but it was still possible. Yeah. So I don't think, like, recursion, again, it was at the very end of the course. It was not fully covered in tutorials and weekly tests. So it's not something that I consider core knowledge for the course. It may come in handy for some parts of it. Some people prefer recursion to looping. And so, as I said, challenge mode for the exam is to not use any while loops and only use recursive functions. And it's still technically possible, I think. Don't quote me on this, but I think it's technically possible to still complete the entire exam with recursion instead of forward looping. But I would only do that if you're really, really solid on what you're doing. Nora is asking if the final exam has style marks, and no, it does not have marks for style. And as Tom's saying there, Tom's answering some of these questions in text as well. So there could be a question that restricts a particular library. There could be stacks and recursion involved, but not in the core questions that you need to pass the exam. They'll be in the harder things. Okay, so question about matching brackets. Zeal is asking a question about night moves. I'll show you a diagram about night moves, but I'm not going to go too deep into it. I don't think it's relevant for most people to be able to do that for now. There are other subjects that will teach you that. Vicky's asking, if there's a multiple choice question with more than one answer, and if we only answer one correct choice, I think it'll just be a raw percentage calculation, where it's like, if it's A, B, C, D, and two of them are correct, and you get 1 out of 2, you'll get 50% for it. I can't remember if that's the exact policy, but I'm pretty sure it is. Ravi's asking in the exam if in a question we didn't pass any of the auto tests because of a mistake, but we have the correct techniques, will we get some marks? Yes, you will. So you're definitely not going to get full marks, but you could have something where your entire program is correct, but then you forget to run the printf command that actually spits the output out at the end. So you fail all of the auto tests, but everything else is correct in your program. If you get that kind of thing where it's like, oh, that's obviously a silly mistake, you're definitely going to lose some marks because you didn't do your testing properly, right? Because we want you to test your things to see whether they work. And if your output was never working, then you never tested it. Or maybe you made a mistake at the end and you deleted your output line or something like that. But even then, you forgot to test it before you submit it. So it's that same kind of situation where we can't give you full marks because the program's not fully working. But if we look at your code and go, oh, this is actually a complete solution, it's just missing this tiny element, you'll still get a significant number of marks. Yeah. Oh, as Tom's saying, Tom's clarifying, the multiple choice questions may have a marking scheme, so there might not just be like a pure percentage based thing. Okay. So I've got more questions coming up now. But let's go back to questions we were getting earlier. So Jingy and Nasa were asking about questions about stacks, and the matching brackets program. So I'll do a little bit of a conceptual thing here, and then we will look at a little bit of code for how to make this. Okay, so matching brackets has the idea that, like, anytime we have an open bracket, we're eventually going to need a closed bracket for that to match. So I have a string of characters that has brackets, only brackets in it. So we're only looking at brackets. And so I've got a square bracket here that has to open and close. And I've got a curly bracket, and then I've got some normal brackets inside it. Another curly bracket. Just looking at this now, we can see that this kind of makes sense. I'll do an example of one that doesn't make sense. So this is okay, and this is not. So I've got my same open closing brackets. I have a square bracket here, an open curly bracket, a square bracket here, and a closed curly bracket. So this whole section in the middle here doesn't make any sense, because the idea that we can open a bracket, put something inside it, and then close it, but without closing this thing inside it, doesn't work, right? So this is actually one of those things that your compiler is going to do, this kind of thing on all your brackets and say, do these brackets match up or not? If they don't match up properly, then we're going to throw a compiler error. So we're going to say, expecting that we expected that this bracket should have been closed, or other things like, it depends on what the consequence of these brackets opening and closing are. That will determine the error message that you'll actually receive. So if we think about this as a stack, what we're going to do is we're going to be putting items on top of each other in the stack. So when we get an open bracket here, this will be the open bracket as the first thing in the stack. Then I get another open bracket which adds another element to my stack, which is this open bracket. When I get the closing bracket, what I will need to do, the closing bracket says I'm going to end the thing that was most recently opened. So let me just get a cursor that I can see more easily. So this is the first thing that was opened, the second thing that was opened. We cannot close this one until this one has been closed. So what we're going to say is, if this closes, so the square bracket closes the square bracket, we're going to say, okay, what's on the top of the stack? This is a square bracket close, and on top of the stack is a square bracket open, which says, okay, that's all right. That makes sense. We can remove this. So the square bracket there is going to remove what was on the top of the stack. And then we have this open curly bracket, which says we're going to add something to the stack, which is the open curly bracket. And then this open bracket here says, yes, we're going to add another thing to the stack, which is an open bracket. And then we go through these closing brackets. So this closing bracket must match whatever's on top of the stack, and it does so that gets removed. Oh, yeah, I can't be bothered erasing it. It's going to take me ages. Then this one is then the next top of the stack, and then this one is the type that's on there. So we can see that the stack builds up as we add opening brackets, and then every time we see a closing bracket, we will remove it from the list, from the stack, if it matches the same type as the opening bracket that had been before. And so we can use stacks in this way to say that the only thing that we're allowed to look at is the top of the stack. So if I get, at this point with this open bracket here, I get a closing bracket for this one, what I'm going to say is the closing bracket I just found didn't match what was on the top of the stack. I'm not allowed to look at this one or this one. I have to close the top of the stack first. So the stack is a data structure that allows us to control whether or not that happens. So bracketing is a really common thing that you might use for a stack. I think, if I remember correctly, you can do the same thing with an undo-redo idea. So if you're editing a document and you undo something, it takes the top of the stack off. And you undo the next thing, it takes the top of the stack off. And then you redo things, they go back onto the stack. And then wherever you are at the top of the document is like what the current document is, but you're keeping track of the previous things that you've done. So we can do that kind of thing with this as well. Okay, NASA was also saying there, though, that you know the concept, but you don't know how to implement it in code with the stacks function provided. So, if we know this concept, we know that when we are going to place, or when we're going to see an open bracket, we're going to add it to the stack. When we see a closed bracket, we're going to take it off the stack. So if we're going to go across and start to try to write this stuff in code, I'm going to create a new file. Bracket match. I'm not going to do this completely. I don't think we have time to go through entire demo. I think I'll take the whole of the next hour to do it if I was going to do that. But we'll do some code. Some of this is going to be pseudocode. Okay, so I have the idea that let's say I get this on the command line. Assuming that we get one string on the command line that only contains brackets. Is that how this question was framed? I can't remember exactly how the question was framed. I know it had some command line stuff, but I can't remember exactly what it was. Okay, so assuming that we do that, then we know that argv1 is our string. So argv1 is assumed to be the string of brackets. So we know that we're going to be using that, and we're going to be using certain elements from that. So what we would then do is I might do something like loop through argv1. Oh, there's starter code for this question. Okay. I assume it was a week 10 question. Was it a tut or a lab question? It was tut, wasn't it? Oh, night moves. No, it was a tut question. Right. Oh, it's Dean's. Okay. This will be easier with starter code. So let's just get rid of everything that we're doing there. We have starter code, and it says we have a function for an opening bracket, we have a function for a closing bracket, and then we have a function that says do the brackets match. So opening bracket, if it is one of these, we return 1. If it's one of these, we return closing bracket. So these are identification functions. So this is us saying, is this an opening bracket or is this a closing bracket? And then if we give two brackets, are these opening or closing? So what I could do is I could say, I'm assuming that is argv1, right? I'm going to say loop through argv1. I would probably have to maintain a stack, but that's cool because I have already got stack.h here. So I'm assuming that I have functions like push stack and pop stack and stuff like that. So make a stack first. And then what I'm going to do is I'm going to loop through argv1 for each element. If it's opening, add it to the stack. If it's closing, pop from the stack if they match. If they don't match, stuff is broken. What's the actual question say we should do if stuff doesn't match? Right, then we just say that it's invalid. Report invalid. Okay, cool. So first thing we do is we make a stack. So I'm going to assume there's stuff in the stack.h that says stack bracket stack is equal to create stack. I don't think that there's anything else in the create stack function. I wonder if we have a stack.h in here. We do. This is, I can see it says April 2019, so it's my old one. Not going to reinvent the wheel. Also, we're not going to be able to run this because I don't have everything set up for it, but that's okay. I'm just making a file in here for it so that I know what we have. So capital S stack, create stack, oh, it's an underscore. Oh yeah, I can see the style was all in snake case here, so I should have started with snake case. So bracket stack, create stack, then I'm going to loop through argv. So I would have a while loop, and I would say while I'm going to need an integer for this, and I'm going to say while argv1 I. So what I'm saying is I'm saying the second element of argv, because the first element's program name, second element is the actual input that we've been given, and which letter of that, because this thing gives us a string, this gives us an individual letter. So while it's not the null terminator, it means we're still in the string and looking at things. We're going to do if it's an opening bracket. So this is nice because I have a function to test if something's an opening bracket. So if opening bracket this letter, I'm going to copy and paste that. So if it is an opening bracket, it's an opening bracket. Add it to the stack. And we have a function to push, stack push, and we have to say which stack we're pushing it to and the item itself. So we say stack push onto bracket stack the item, which I still have copied. Yeah. So opening brackets always get pushed to the stack. There's no other behavior we're going to do for opening brackets. The only thing we need to do is to figure out whenever a closing bracket happens, has it been closed in the right way? So I can say if it's an opening bracket, we do this. Else, if it is a closing bracket, so if the element we're looking at is a closing bracket, check if it matches the most recent opening bracket. Oops, don't need that autocomplete. Sorry, lots of stuff happening in chat. I should actually look at what's going on. Oh, people are asking lots of questions and Tom's answering. That's great. Wow, there's someone called Computer Science. I think you made an account just for this, right? No, there are no help sessions. The help sessions ran up until the first exam deadline. However, if you do need help now, if you post on the forums are still active. If you do definitely need that level of one-on-one help, especially if you had an extension on the assignment, you're still working quite hard on it, you can let us know, and there's a chance that we can give some time to your tutor to talk to you and that kind of thing. Anu says, the question says that there are opening closing quotes. So does that mean we start from argv11? I'm not sure. As Tom says, as a tutored question, it's really open to be taught by the tutors. It doesn't have this kind of hard structure the same way the lab things were going to be. Raymond's asking, Yoda is still there behind me. Yes, Yoda is still there watching over us just in case. Okay, so if it's a closing bracket, we check if it matches the most recent opening bracket. So how can we do that with the stack? We can pop from the stack and see if it's the same. So int top, I'm going to say, so the top of the stack is equal to stack pop bracket stack. Actually, no, it's just bracket stack, I assume. Yes. So we take the top thing off the stack, and then we're going to ask if they match, which is brackets match. Brackets match, and I have an opening and a closing. So the opening bracket is the one that was on the stack, because the things that are on the stack are the opening brackets. So that's the top of the stack. Does this match the closing bracket, which is the current bracket we're looking at? And so we're going to say this is an if. If the brackets match, then we're okay. Otherwise, they did not match. If the brackets didn't match at this point, then we have a problem. Invalid string. So that's the invalid string of brackets. This is so funny, it's like I'm teaching a tutorial. Then I can say invalid bracket sequence. only if all of the brackets are finished and they've matched can we say all brackets matched. So what I would probably do here is in this invalid string, I would probably change this if else, because this one doesn't do anything. But for the moment, I'll just show you this. So if the brackets didn't match, I'm going to say printf invalid string brackets didn't match. And I'm going to return a 1 here to say that this is different from the normal return 0, but we're definitely going to end the program the second the brackets don't match. Otherwise, if we can get through the while loop and never hit the point where the brackets didn't match, then I'm going to print out. I'm going to slow down my typing so that I can type a simple word like printf incorrectly. I get like this when I get excited and my brain is thinking about the concepts faster than my fingers can type them in. What was the output? All brackets match. I mean, as a tutorial question, I could say whatever I wanted here. Put a new line on the end of that just to make it neat. So this is the kind of code that I would have for that. I would say anytime there's an opening bracket, it goes in the stack. If there's a closing bracket, we check it against the top of the stack. So we pull off the top of the stack and we say, is the top of the stack the opening bracket that matches that closing bracket? If it do match, then we keep going. If they don't match, then we would exit. So that's an example of us using a stack, this stack here, the bracket stack, to decide whether these brackets all matched up correctly or not. So if we look at this one here, we would add, let's make a new stack. We would add this opening bracket to the stack, and then the curly bracket here, we would add the curly bracket opening to the stack, and then we get this close bracket, and what we would do is we would pop this off the stack, and then we'd say this and this, do they match? They don't match, and that is the point at which this would say invalid string brackets didn't match, and then return 1 and exit. There's another issue here that we might get to where we could pop too many things off the stack. If I just did something like, oh, actually, I don't know. If I had something like this, and I tried to pop too many things off the stack, I would be in trouble there, because I would be causing the stack, you know, like we were throwing big errors if you tried to pop things off the stack and the stack was empty. So we'd have to check for stuff like that as well. We might put in other cases. So I've worked against some cases here, but not always. So I would potentially have something to check here before the pop. I would check using stack size, and if the stack size was 0, then we have an invalid string as well. So there's other things I might add to this. Yes, exactly, Nasa. How do we check if the stack still have any brackets left? I would ask the stack size here. So before I do any pop, I would say, let me just check what the stack size is. If the stack size is down to 0, that means I have too many closing brackets for the number of opening brackets I had, in which case it's also an invalid string. So that's something I would potentially add in here. If, what's the function? Stack size. Bracket stack is less than or equal to 0. I mean, like, I don't think the size is going to be equal to 0, but I might want to check anyway. I'm going to use that same thing. No more opening brackets in the stack. To match this closing bracket. Yeah, so I've got that as well. So if the stack size is 0, or if the stack doesn't have any elements in it, then I've got a problem, because I just found a closing bracket which was supposed to have something in the stack to match up against it. So if it's 0, then we can't go on. Otherwise, we pop whatever's on the top of the stack and we check it. Okay, let's go back. Okay, so that's a bit of information, not just about stacks, but about how we might use this stack.h. And the funny thing about that is that the I didn't even look at what's inside the stack.c. I just assumed that these things were going to work and follow the rules of the stack. So that's very, very much that kind of abstract data type usage that I'm showing there. So when I'm working in the main here, I just assume that the stack has worked. Someone else made it. I mean, it just happens to be me that made it. But past Mark made this. Current Mark is working on this other thing. Okay. So hopefully for... who was it? It was Nasa and Jingyi. That gives you a little bit more information on how stacks work. Lynn was asking a question. What is the meaning of lack of use of constants? I think that was in one of the style questions, the short answer style question. So that's when someone's putting numbers in their code where they should have had constants. So good example of that is this one here. This is a good use of a constant for a max size. If instead I did this, like 1024 here and stuff, then that's kind of dangerous because we don't know whether this is always going to be fixed at that size or not. We much prefer magic numbers for things that are like specific quantities or rules for things that happen. Then we prefer them to be in hash defines. They're much easier to read. So we know that this is an array of the maximum size that we set out in the program, you know, that kind of thing. I think Tom's probably already answered that because that's from a little while ago. Raymond's saying, when would you justify it to be enough hash defines? I would say enough hash defines are the point at which you'd never have any numbers in your code that you might need to change later in more than one place. So if this 10 here was the number of players in the game, and there was many other places where the 10 existed, that's something I need in a hash define. Even if there's one other place that this thing exists, we want it to be so that if there are any numbers in our code and we change them, we don't have to look anywhere else in our code. So if we change the number here, and it changes things, like if I just do this, then everything else in here still functions correctly. It just changes what the maximum could have been. We don't want to have a situation where we have a number floating around in our code. So I'd say the correct number of hash defines is so that there are no numbers floating around in our code that can trip us up by being in more than one place at a time. So I would say that is the, and that is enough hash defines, enough so that you don't have a number that can trip you up in your code anyway. Oh, Tom's right. Tom said exactly the same thing. Enough means that there are no magic unexplained numbers. Yeah. So I think I said a really long-winded version of what Tom said there. Anu said the question says that there are opening and closing quotes. Oh no, that's right. We've looked at that already. And the thing about Yoda, yeah. So Kat's asking a question. Had an int function once and wanted to call it, so I assigned its value to a variable, but got a warning that the variable is unused. Oh, we've got that here. So the warning is unused variable number reached, which is this one here. So we've called an int function here and we've saved its value there. But since we never read this value afterwards, the program's asking us, did you need that? Because you have a variable, you've created a variable and given it a value, but you've never used it. So what was the point of it existing? So the warning is there to say, look, it's going to run fine, but you've got stuff that you're never using. So you allocate it with, it's stack memory, but you're still sort of allocating memory for an integer here. And you've said, okay, I've set up an integer, I've stored its value, but if I never read it, then what was the point of it existing? So that's why you'll get that warning. And often it means that you've saved some information that you forgot to include later in your other calculations. So I say it's a good warning because if I'm not using this number, then why am I giving it back and why am I storing it? You know, so it's a good warning because it gives you the ability to go, okay, I need to look at this and figure out whether it's useful or not and what I need to do with it. And as Anu said, you could change the function to void if you don't want to use the integer that it comes out. But if you did want to use the integer that comes out of it, then you would store it and then use it. If you don't care about the integer that comes out of it, so sometimes you care about the integer, sometimes you don't, which is what you're saying there. You used elsewhere as an int function, so couldn't change it for what you remember. But you don't always want to get the return. You can call an int function without saving its output. So this will transform itself into a number. It's actually like saying this. If I want to, I can declare a number. It doesn't do anything. But it's not actually... Actually, I need to check on this. Let's compile this and see what it does. There you go. On line 11, you're performing an operation but not saving the result. Did you mean to print or store this result in a variable? So, I can if I want to, in the same way as I can run this function that will turn into an integer just like this, into a value. This isn't really an integer because it doesn't have any memory, it's just a value. This turns into a value but we don't store it. And we can do that if we want. In the same way that if I really want to, I can have a number that I do nothing with. It's still legal C, it's a warning, not a compile error. So if somewhere else in my program I would call that function and use its number, then I can have the function like this and I can say I'm just not going to take the output and it'll still run. As Tom says there, you're allowed to just ignore a return value. Yeah, that's a good answer, Tom, that printf and scanf are always giving us values. I think that they're giving us... Scanf is giving us the number of things it read in. Printf, I think, is giving us just a success value. Oh, Nasa, good question about the stack. What if there are more opening brackets than closed brackets in bracket match? So we had another... Oh, hello. Someone just jumped on my lap. Want somewhere to sit. Oh, Tom's saying that the number of characters for printf might be the answer. So Nasa was saying, what if there are more opening brackets than closing brackets in the bracket match situation? So if we get to the end of the loop, right? Okay, so let's look at the situation. The situation is, what if this happens? And so that is incorrect. So we actually need to check that at the end the stack is empty. So I'm going to say if stack size of the bracket stack is equal to 0, then all brackets match. Oop, just hit her in the face. Otherwise, we get the same one. Oops. I meant to copy that, not cut it. Oh, I did it again. I keep pressing Control X. Right. Yeah. So this is nice, actually. As we've gone through this bracket stack thing, you realize that this is our testing, right? Where we have our general case, which I did first, and then we have all these edge cases. What are these other situations that things could be in? So this is a really good example for how an exam question might go. Bracket matching is actually something we've used in an exam in the past, where you would... And when we use this in an exam, you had to make the stack yourself, actually. So we would do the basics, which is like, do all closing brackets match opening brackets? And then when you do your auto test, it would be like, well, what if there were no more brackets remaining? Have you checked for that? And it's like, oh, no, we haven't. We add that in. And then the auto tests show you, well, what if there were extra opening brackets at the end? We didn't check that the stack had been completely used up by the end, so we'd add more things like that. So these are the things we call edge cases, where there's like the main idea of how things should work, and then there's the edge cases of the capabilities, like, you know, what happens if there's this thing on the end? And that's why it's called an edge case. It's on the edge of our data. It does something different. So as we do our testing, we get more information. We get better at saying, okay, this is how this should or shouldn't work. Jingyu's saying got it. That's great, and Nasa also. So I think that this little extra work on the stack hopefully has helped people a bit there. Do we have any other questions? Zol's saying that worked. So the stuff. Which was your question, Zol, earlier? Just scrolling back up. I'm not sure which one we were talking about from you. Yes, okay, so we were going back to that question about splitting the list, and so that idea got you to the end of that. That's cool. Oh, there was another question about night moves. I think that was Zeal was asking about that one. Where I'm scrolling back up through the questions now to see it. I will show you something about night moves. I'm not going to go too deep into it because we have 40 minutes remaining, and I don't know if I could do an implementation of night moves in 40 minutes while explaining it. If I went like full on high speed coding and just smashed it out, yeah, I could do it, but like, I think that's like, it's not going to help you at all. It's like, I don't know, maybe watching people speedrun is fun sometimes, but not when you're trying to learn something. Okay, so here's night moves. I'm going to throw in some extra capabilities that we may not have had. So I would potentially, depending on, I haven't thought about how I would structure the data for this, but the way that night moves would work is I would have a struct saying what position I'm in. So this would have the coordinates of the position that I'm in, and I would think about having a linked list of pointers inside here, and the linked list of pointers is the nodes that can be the next state of the game after I make a move. And so there's several different places I could be. So if we just do a really, really simple, not going to do a full-size chessboard, but let's say this is my knight here, and I say the next positions that I could be in is this one, N1, and N2. So these are my next positions. So what I would actually have, so we're getting serious here. I am not making a linked list. I am making now a different data structure. So K was the starting position. N1 was the next position. N2 was the other. N1 and N2 might be in a really specific order because Night Moves says that you should print these out in alphabetical order. So I think rows and columns, N1 is on a lower number row than N2 so that it will get placed first. Then let's just say I've got a target location as well. So I have my target location. Oh, that's really easy. That target location, because both of these are going to reach the target location. Actually, it makes my example much easier. So let's say N1 can then lead to, I'm going to call it NN. Oh no, wait, N1. I'll do N11. So N11 can actually go here. N11, and it can go here. N1, 2, and it can go here. N1, 3. So N1 might have, oh wait, sorry, the important thing, N1, 4. So from N1 we can reach these 4 different locations. N2 is going to have 1, 2, 3, 4. Also 4. I'm not going to bother drawing it. I could keep doing this. And if I want to, I could check whether any of these locations have been here before by saying I go back up. So maybe I would have a pointer that goes the other direction as well. So I'd have an array of pointers, or a linked list of pointers to the futures, and a pointer back to the past. And then I would say, okay, I'm going to look through all of these and I'm going to check for certain things. So if it is the same as the past, so that's N11. This is going to get more complicated the more I try to draw, so I'm not going to draw much further than this. So I say that I'm going to cross out N11 because it's returning to where I've been before and I don't want to go back there. So this is me moving the knight here and then moving it back. I'm definitely not going to get the shortest if I follow that path any further. N12 is a possibility, N13 is a possibility. They could eventually get to the end point, I don't know. N14 happens to hit the end point. So I'm just like, oh, okay, that's my endpoint. So then what I say is, this path I would build in reverse. So this is the final step of the path, this is the step before it in the path, and I keep going up. So I follow my parent pointer back up until I reach the starting point, and I go, okay, that's my shortest path. But then I would look through all of the other nodes here to see if any of them also hit the shortest path, and then I'll print them out as well. So when it comes down to it conceptually, me drawing it like this, it's not actually that difficult. But let's just wind back a moment and think about the fact that when we're in 1511, I haven't taught you anything about putting multiple nodes chaining off one. So this is something that we call a tree structure, which is an expansion on the idea of a linked list structure. So, but you can actually see that now that I've done it like this is actually not a super difficult question if you can get your head around this, but now translating this into code is not easy either, right? So there's a lot of work going on there. So Zeal's saying that means we save the paths in a queue. Well, it's sort of a queue. You could think of this being a queue because the only things we're going to add to this are things that chain off it. And then we would wind back through this. I wouldn't call it a queue because there's multiple nodes off each one, but you could kind of consider each run through to be its own queue, where the next thing is always the thing that gets added on. But we're not going to be adding and removing from this tree. We're just going to be adding until at some point we add the node that's going to be the finishing node, and we go, okay, we stop. That's the depth we go to, but we're going to check the depth of all possible branches of the tree, and then everything at that depth that reaches the target is one of the lines we're going to print out. And then we would print out by going back up through here and going, okay, this is a path. So it's this node, then this node, then this node. Yeah. So yeah, it's, when you think about it and you look at this, I'm only doing pointers and node allocation and a struct. So all of the techniques we taught are fine for doing this, but in terms of like problem solving for complex sort of situations, we haven't got that much practice in that yet. So this is the kind of thing we're going to ask in question 8. Can you use the tools we've given you to solve problems you haven't seen before? And you can see how that is testing your knowledge of these things. So basic knowledge of things is like, can you do things exactly the way I did them? So can you just loop through a linked list? Advanced knowledge is, can you manipulate those things the hard way? So can you start moving pointers around? Do you understand what it means to both allocate and free memory? Can you manipulate pointers to skip things in lists, or can you manipulate pointers to squeeze things in lists, like insertion and removal, right? And then the super advanced level, which is like those people want to get HDs or higher, is this kind of thing where what I'm saying is, can you take the things I've given you and extend them beyond what I've taught you to do with them? And then can you do stuff like this? And this isn't the only thing, right? Because when you think about the extension of what we've taught you, so we've taught you programming fundamentals, the extensions of it are, there are many, many different possible extensions of the kind of thing we've taught you. So this one is really specifically an extension on the complexity of the next pointer in a linked list. That's all it's about. The other thing about this is, can you identify that that's what you want to do to make a to make the solution to this problem? So many people are going to look at question 8 and say, oh, I know how to fix this, I will do it like this. And then you'll get a part way into it and you'll go, that's not how this isn't going to work like this. You'll get to a point where it's like, I can't code this, it doesn't seem to be physically possible. So it's like, okay, we need to wind back and try approaching this in a different way. So it's not just going to test your ability to expand on techniques, but your ability to identify how you're going to expand on techniques to get stuff working. So, big questions, but when it comes down to it, if I was to say this to anyone who's in, I don't know, even second year programming, I would expect them to solve this, right? So this is the kind of thing where it's like, you will learn this later, but for now it's very hard. And that's how a lot of the exam stuff is sort of calibrated. And it's also interesting because when you look back at the first tutes in the course, the first tutes and labs, what we considered a reasonable level of difficulty for you, now you would look back at those and you say, well, that's easy. All we did there was printing out characters. Like, we're not even doing any conceptual programming. We're not doing any problem solving or anything. So this is the same kind of thing. These questions now look hard. In a couple of years with a bit more experience and stuff, you should be able to look back over them and go, okay, I can do these now. I mean, some parts of it, you're going to look back and go, oh my god, that's still hard. Talk to me about linear algebra. I have to relearn it every time I teach it. Right, stuff like that, yeah. Yeah, so I think people are talking that. Anu was saying, I think that at this point, at time 2 moves, we could check how many of these nodes have reached the target, yeah. And so knight moves on a full chessboard, you're not going to get there in 2 moves, you might get there in more moves, in which case this tree gets bigger. This tree gets exponentially bigger because every time you add a level to the tree, for every node there, you multiply by the number of possible moves you could get. And also, the closer you get to the middle of the board, the more nodes you have off each particular node, right? So these ones only had 4. The maximum number of ways a knight can move in chess is to 8. 1, 2, 3, 4, 5, 6. Yeah, 8 different positions on the board, and so this can get really wide. Having said that, doesn't matter. If a computer is dealing with it, it doesn't matter how many things there are. But for a human to conceptually think about it's very difficult. And this is why chess is one of the classic games for sort of critical thinking and planning ahead, is because the number of possibilities in the near future in a chess game gets to a number that humans can't really fathom. So you have to try to use memory tricks to pattern match different things, or focus on particular strategies, which means you ignore some of the futures and focus on others. And lots of artificial intelligence is based on the same idea. How do we look into the future of the world and many, many different possibilities for the future of the world, and pick out the ones that we want to analyze so that we can get the result we're looking for, or we can manipulate the possible factors going into the future so that we can go towards the ones that we think are going to be more positive for us. So plenty of artificial intelligence is really just about looking into different likelihoods of the future and reporting what the different likelihoods of the future are, or trying to shift the future from the things that you can change into the things that are going to be what you want. So this is that. Looking into the future, seeing which outcomes are definitely not useful, which outcomes are useful, and saying, okay, this is an outcome that's useful. This probably isn't. I wouldn't call this an artificial intelligence because it's not. It's not thinking about what it's doing. It's just looking into the future, looking at every possibility. It blows out to massiveness really quickly. What's the statistics are your average chess game finishes, or at least forfeits on average somewhere after I think about 60 moves, and on average the branching factor, which is the number of next moves coming off each node in chess, is about 30. I'm just ballparking these figures. I know them. I've got them written down somewhere, but I can't remember. So if you have 30 to the power of 60, oh no, it's 60 to the power of 30. So 60 is the depth, and then the branching is how much it multiplies each time. So 60 times 30, no, not times 30, 60 to the power of 30 ends up being a number so large that no computer that has ever existed has had that much memory to store all the possibilities. In fact, we can add up the memory of all the computers that have ever existed, and it still won't be enough to store all the possibilities for just a basic chess game. So we then start to think about, okay, how do we only look at some of the possibilities? How do we draw a picture of the possible future based on the abstract nature of the game, rather than trying to enumerate all the possibilities like this? That's a field that some people may end up going into. You can kind of tell that that's the field that I've researched, because otherwise I wouldn't know that much about it. But yeah, there's some stuff there that in the next sort of 3 or 4 years you could look at this. Zeal saying, could you show how to use recursion to implement list reverse? My current version is a little complicated. I used 4 pointers. Right. I don't think we need any pointers for list reverse with recursion. Didn't I do this? Isn't this something that I did in lectures? Do you remember this deal? I thought I did this. Lecture 16 was the last time I wrote code. This is reverse list here. Okay, this is the reverse list. Oh, you're talking not just about printing them out in reverse, but you're talking about creating a list out of the pieces of a list. Okay. And doing this with recursion. Passing pointers around. This is an interesting one. Okay, alright. New thing. Oh, I don't want to save that. I don't need to save that. Like, save everything that I've ever done on a whiteboard. Okay. So we have a linked list. And let's just say this is A, B, C, D. And this is my null here. The outcome we're looking for I should have drawn less notes. Is this D, C, B, A, without allocating any memory and only manipulating the list that we have there. And we want to do that using recursion. Okay. I think I can think of how I might want to do this. I'm just gonna reverse list dot C. We're not gonna get a full solution here. We only got 20 minutes. Yeah, Tom's like, yeah, this seems weird. Okay. So we're going to have a function that has, okay, we're going to need a struct node let's just put an int in it because I'm just going to go easy on this. Int data and another node pointer. So what I'm thinking of is we're going to have recurse to the last element, stopping case uses the current element and makes the rest of the list into the tail of the current. I assume it's going to be a node pointer function, but we'll see. Reverse list, and this is going to take in the current head of what it's looking at. So I'm going to try to bundle this into a single function. I don't know if this is going to get messy or not, because as I am writing this, I still don't have a clear idea of what I'm doing, but if I'm going to recurse this, I know that my stopping case, single node. Oh, actually can't do single node. No nodes, return head, going case, head next is equal to result of reverse list. That might actually do it. I think that might be all I need to do. Okay, so Tom's racing me here. So if head is null, return head. So we have succeeded if the list is empty. Otherwise, if the head is not null, then the head exists, so the head's next will be equal to reverse list of head next. Am I done? Am I done, Tom? I think this might be the entire program. So this is where I need to think really carefully about what are the order of the things that are going to happen. So I would then draw out the same kind of thing that I did. You know how I did that order of operations graph? So I would say, okay, the first thing that my thing does is it checks if the head is null. If the head is not null, then the first thing it will do is it will call reverse list, and then it will apply the result of reverse list to be the next of the head. Oh, I need to return something. Yes. In both cases, we're returning the head. This is like we're just changing this to be something. So if this is all I'm doing, the basics are stopping case, no nodes, return head. I'm going to put this comment inside the if statement because I prefer them to be inside if it's after the decision has been made. My going case is make this node the head of the rest. No, it's not actually making it the head. Connect this node to the rest of the list. And it's already connected to the rest of the list, but it's going to come back in a different order. So Tom's thinking that we might be setting the reverse list head next of next. So we might be setting the output of the reverse list to have us as its next. Yeah. Yeah, because the way that we want this to end up is we're putting something before something else. So if I say, as I'm going through the list, so I'm going forwards through the list, if I say my next is equal to the rest of the list, then I'm going to keep it in the same order that it was in. But if I flip that around and I say, this is the rest of the list, so I want the rest of the list to come before me, so that's what I'm going to do if I'm reversing it. So I'm going to say, reverse the rest of the list, and then put me after the rest of the list. So the next of the rest of the list is equal to what I am now. That is going to break our stopping case. We might need a stopping case for a single node rather than a stopping case if there are no nodes. So we're going to need 2 stopping cases. Else, if head next is null, so if there's only one element, then we stop recursing there. Because what we're going to reach is this point here, and we need this to come back as a result of this so that its next can be put there. This is a special case if there were no elements in the list. So I'm going to say this is a special stopping case. And this will only be reached if it's an empty list, and then we return the empty list. Otherwise, if there's only one element in the list, and we needed to check for this first because we can't call this unless that. Having said that, these two do the same thing. Yeah. That does the same thing. I don't need 2 stopping cases. Empty list or only one element remaining. I can do that in one test. There you go. So, if it's empty, or if it's not empty, so if this one hasn't already passed, then this one can run. Then we stop and we just give back what it was. So either it's null or it's the final element. And then this thing is going to go through and say the rest of the list goes before the current element. Yeah, Zeal, you picked up on that as I was writing it. Yeah. So we can still make this neat like that without doing a whole chain of if-elses. So I think this is it. I don't know. I would have to... Let's copy a whole bunch of this stuff in. Actually, let's do it the other way around. Let's see. Copy that. Oh, I shouldn't change that. That's the previous that's from previous lectures. I want to keep that stuff as it was finished there. Tom's like, yeah, this is a bit of a mind bender. Yeah. But I think this is what we're doing with this recursion here, is we're saying that call this on the rest of the list. Okay, let's draw it. So, at the beginning, the first point, we look at A, and then we say rest of the list here. And what we're saying is call it on the rest of the list and put A afterwards. So the rest of the list, we don't know what it is there. And then its next goes to A. here. The thing that we need to be careful of is this isn't complete, because where is this thing pointing? If it's still pointing at B, we've got a problem. It should be pointing at null. But anyway, if we call this on the rest of this list, then we would say it is B, and then C and D go before that. So we would end up with a B here. And then we'd have, let's use a different color for that. And then the B would then be connected to the A, which still has its problem of its next not being aimed anywhere, but I think that that is what this would do. So this is actually different now. So we can't just return the head. Head next is null. This, connect this node to the rest of the list. That's the head. There's an issue. So the deeper issue is this last thing here. How do we know that we were the first element in the list, and then we have to be equal to null afterwards? Tom, the recursion police are here. Was there a siren outside? I've got to the point where I just ignore the sirens outside my house. Wait, you're saying save reverse list and return that? Oh, I shouldn't be returning the head. I should be returning this. Okay. So the node pointer, is it the new head? I guess it's the new head. Is equal to reverse list. Then the new head next is equal to the head, and then we return the new head. It's not as simple as I thought it was before. And then when we get to the end, is it going to add null itself onto the end? No, it's not. Sorry, my style. Yep. So, you'd make a new head as the reverse of the rest of the list. So that is the new head of the list. And then after that's done, you add the current node onto the end. So that is going to be reversing the order of the elements correctly, but whether or not we're getting this pointer still aimed at the B. So the issue that we have here, because we haven't changed the pointer from A, is this. That's super bad, because then your list never ends. So we would have to make sure that that thing changes. But it would have to change only after you've used its next. So there's a super complicated edge case there, which I'm not going to go into. But you're going to need a way to figure that out. So the very first time this calls, it has to behave differently. So it's not a simple recursion. Oh yeah. Too busy thinking about the abstract problem here. Okay, so I think that this, what we have here, would reverse the elements of the list, but it would leave this hanging pointer here. So you need to identify which node was the very first element of the list. So it's nearly like this. You go... Okay. Struct node pointer head is equal to, I'm going to assume that I have functions elsewhere that can create stuff. Then I'm going to do build the list somehow, then I'm going to say struct node pointer reversed list, I should maintain my style, is equal to reverse list of the head, then head next, set that to null after you've done that recursion for reversion of lists. Recursion for reversion of lists causes an inversion of your brain, and I don't know, yeah. And this might do it. It's clunky to have to do this, but you go, okay, save the node that used to be the first element of the list and set it to null after you reverse the order of the things in the list. I would potentially think about putting this inside a function, but you can't put it inside the recursive function, because if you put it inside the recursive function, it will change every element like that. So, fiddly. Recursion's fiddly. Having said that, even with this, and this, I've still written significantly less code than I would have written if I wasn't using recursion. But I would hazard a guess, I would be open to arguing that this still took me longer than it would have if I just didn't done it the other way. Because how much did we have to invert our brains to make this work? And it took a bunch of us talking about it to try to figure this out. So this is one of those cases where, yes, recursion may help us, but it might not. Recursion's one of those things. It's going to take a bit of practice to get a handle on it. Okay, so we're nearly at 4 p.m. I think that the questions have dried up, considering the last two things that I talked about were night moves and recursively reversing a linked list. I think people have gone into the fantastical realm of what if programming, not what are we actually focusing on programming. So yeah, so let's just wait for a moment and see if there are any final questions. If there are any final questions, I'll answer them. Otherwise, we'll wrap up because we're pretty much at the end of our time today. No, it's fun, Zeal. Like we've covered lots of different things today, so I have no problem with having a look at these things. I'm wondering if there's anything that I should be uploading. Not necessarily. Maybe the bracket match, if anything. But I have a feeling that your tutors have all done this as well. Maybe I'll upload this one file, this bracket match file, so that people can use it if they want to. You can put it in your study notes for tutorial 10 and stack implementations and things. Alright, looks like there's no more questions. Thank you all for coming along. This will be the last time you ever see me. Not true. We'll see each other around CSE eventually. I'm hoping that, you know, it's not going to be too long into the future. We can all be back there. If you ever go to things like CSE Sock barbecue or something like that, I will turn up to those, and other little events here and there, and we'll see each other. Zeal's asking if I teach any other courses. Third term next year, I'm teaching computer graphics. I don't know if you'll be in a position to take that yet. If you can do enough courses between now and then to get the prereqs for it, you might be able to. I think it's actually potentially possible. Like a whole year on from now, you'll have enough knowledge. But we see how we go. Otherwise, I'm pretty focused on 1511. So I may not even be taking computer graphics every year, because I don't think it's a subject that needs to happen every 12 months. Even if it happens every 2 years, that's enough to cover everyone who's actually interested in it. Yeah, so you're welcome, Zeal. Thank you also, Alan, Anu, and Kat, who are still here at the end. I'm sure there are other people here anyway, so thanks everyone, and I wish you all the best of luck for next week in your exam. Remember that the forum is still open, so if you do have particular questions about what you're studying and stuff like that, and you want to get some more information and things, we're happy to still answer your questions there. So we're still sort of around. It's not going to be the sort of fever pitch of the forums where we had heaps and heaps of people watching them to try to get your question response time really low for the assignments. But if you have questions, we're still going to answer them. You're welcome, Vicky. Thank you very much for coming along. Okay, I'll wrap it up there. Thank you all. Hopefully this final thing here helped a little bit to answer some questions about the exam. And good luck for next week. Bye.